Random sampling, as the name suggests, is a method where each individual in the population has an equal chance of being selected, which makes the process akin to drawing names out of a hat. By giving every person an equal opportunity to be included, random sampling maximizes the likelihood that the sample will accurately represent the broader population. A simple example would be assigning numbers to everyone in a population and using a random number generator to pick participants. This approach minimizes bias and maximizes the likelihood that the sample is representative. This quality is what makes random sampling a preferred choice in large-scale surveys and experimental research, where the goal is to ensure that the findings can be applied to a larger group. One of the most notable strengths of random sampling is its ability to provide high external validity. Since the method does not favor any particular subset of the population, the findings from a study using random sampling are more likely to be generalizable, meaning that they can be applied to the wider population with a greater degree of confidence. Another key benefit is the reduction of systematic bias. In other sampling methods, certain individuals or groups may be overrepresented due to the researcher's influence or convenience. With random sampling, this risk is minimized because the selection process is completely unbiased. The random nature of the method ensures that personal preferences, biases, or logistical factors do not affect who is chosen for the study. Despite its many advantages, random sampling can be challenging to implement, particularly in studies with large populations. Some of the main drawbacks are the time and cost involved. To conduct random sampling on a large scale, researchers need access to a complete and up-to-date list of the population from which they're drawing their sample. In some cases, obtaining such a list can be difficult or impossible, especially when working with fragmented or hard-to-reach populations. Additionally, there can be significant logistical hurdles. In small populations, random sampling may be fairly straightforward, but when dealing with larger populations, coordinating a random selection process can become complex. This can involve significant costs, not just in terms of initial recruitment of participants, but also in terms of travel, communication, and follow-up procedures. Given the costs and logistical challenges, random sampling is best suited for large quantitative studies, particularly those where generalizability is the primary goal. If the research is designed to draw conclusions about the broader population, such as in public health research, market research, or large-scale sociological studies, random sampling is ideal because it provides the most unbiased and representative data possible. In cases where time and budget constraints are more pressing, or where the research is exploratory rather than aiming for population-level generalizability, other sampling methods such as convenience or purpose of sampling might be more appropriate.